thinking, Benjamin said I should use our course for the rewrite and release, and I'm like, I want to use that.
Alrighty, go time. Is that too loud? Is that good? Awesome. Can everyone hear me? Okay, cool, good. Okay, so this is building a better package ecosystem. So I'm rhyselsmore on Twitter, and first of all, thanks for having me. Yeah, Japan's pretty beautiful and the people are wonderful. And I didn't know that 98% humidity existed, but you guys do it really well. So anyway, I work for Heroku, fantastic people. And I want to jump back to the title of this presentation. Basically, I think it is a little misleading when I submitted the abstract. Some people might hear packaging and just sort of think, oh no, he's going to talk about dist-utils versus setup-utils, or IDE for pip or PyPy, or a package which imports from pip at runtime. And that's not really it. I mean, I want to concentrate on the words better and ecosystem. This is what I'm going to talk about, basically the packages we use day in, day out, and the packages that don't exist yet. So the state of packaging within Python, we have virtualenv. It's the de facto for isolation. It's fantastic. It ensures that your packages don't leak from your system-wide directory into your app's environment. We have pip. What can I say? For the most part, it's pretty good. You know, pip combined with PyPy does have its trouble, but as a whole, virtualenv and pip are pretty good. You know, they're a solid combination for installation, for isolation and declaration of your dependencies. The link down the bottom, I am going to be putting these slides online. Basically, it's a link to the 12-factor application, a bit of a brainchild of some of the guys I used to work with. It's basically best practices for building an app. There's a bit more on dependencies and isolation down the bottom. So, also within packaging, you know, we've got setuptils, distribute, dist-utils, dist-utils2. I'm not going to go into it. Armin Ronacher, he gives some great thoughts on the current state of package managers in that link down the bottom, far better than I ever could. So, no, this isn't about any of that. I'm going to mention them, but I'm focusing on a different area. So what I do is web apps. You know, for the most part, when I'm developing at Heroku, this is what I'm talking about. So let's say you're building an application, a web application. You choose your framework. You know, it can be Flask, Django, Bottle, anything you really want, even Rails, if that's what you want. You've built your models, database is set, you've got your CRUD interfaces, so data can be validated, retrieved, updated, deleted. You can create new resources. You bolted an API onto the side. Templates have been shipped. You know, nice and pretty. But what about the logic, you know, the business part of your application? What makes it great? I'm talking sending emails, metrics, push notifications, storing uploads. And for reference, that link down the bottom is great. It's good, very good reasons why you shouldn't store your uploads to disk. I tend to use a backing system like S3. It's a pretty good read, I'd give it a go. You know, error tracking, caching. I'm talking about the batteries that aren't included in the frameworks. And most of the time, these are going to involve more code. And since we all use Python, most times we're going to turn to open source. So how do we find these packages? You might Google it. You might search on PyPy. You might use the hashtag lazy internet, which I found is absolutely fantastic for finding out something. Searching on GitHub. I've distanced myself from Hacker News. I don't really enjoy it, but I'll usually use GitHub as an indicator for what's hot. This link down the bottom, it goes straight to their trending Python packages for the last month. So it looks a little something like this. You can see what's got a lot of commits recently, where the activity is. Also, up the top right, you can see stars. You can sort by the most popular starred packages on GitHub. Within the first 20 pages of starred Python repositories, you can usually find the right tool for the problem you're trying to solve. Also, it's good for a jaunt through just to see what's going on. So, you know, you can do all that, or you can write more code. We're developers, though, and if someone's already done a great job, we want to use their tools. There's always SaaS, so software as a service. For example, I could write my own error tracking system, or instead, I can go to Get Sentry. I can choose a subscription. I can install the client. I can set the client up. And I have error tracking. I don't have to worry about anything managing this service, except, you know, all I have to worry about is, except how to, you know, I guess how to solve those bugs that it's presenting me. So this idea of SaaS, in terms of paying a third party to manage the component of your application or a certain component, be it mail services, error reporting, push notifications, metrics, this idea of backing services, it's something that I'm growing ever fond of. 12-factor specifically details backing services, or resources as they're known, and how you can obtain flexibility, choice, and some form of dead prod parity when using these. So yeah, I'm a big fan of paying for them and using them to my advantage. So we've gone through all those, and you go through all those steps, you look for your package, you look for your component that you want, and you turn up empty-handed. Nothing appeals to you, and you don't settle. But there's a lot out there, so how are you not settling on something? We take a look at PyPy, and there's over 30,000 packages there. Some great, some not so great. Just while we're on the topic of PyPy, check out this package, download it, don't install it via pip, and just read through the source. It's a real package. Visit that link, check it out, and remember that that's real, and we put a lot of trust in these packages that we're downloading to our local machines, so be ever vigilant. So back to PyPy. We've come up with no results. For the next part, I tried to find a good list of SaaS providers, so I looked at the Heroku add-on marketplace. Over 100 add-ons there, we haven't found anything. So why haven't we found anything? There's many reasons. Could be the security of SaaS. We might have an obligation to not put our data in the cloud, in a third-party cloud. Might be the cost of SaaS. So you might be running on a tight budget. The idea of budgeting concerns when it comes to SaaS, I think, is crap. You get an absolute lot of value from these add-ons relative to the cost, and I think that's amazing. We might find packages which could use improvement. So, they might not be there yet, they don't work how you want. The packages might not be actively maintained. Or there might be a high barrier to entry. So some of them might have the steps that you're not prepared to or capable of investing the time in. Might not have found the features that you need, or there might be too many features. And then again, the package might not actually exist. And that's all okay. You shouldn't really settle for second best. If you have to make extreme or limiting compromises within your existing code to introduce more features, you shouldn't really settle on it. You should feel comfortable about introducing logic via new packages or a SaaS provider. If you don't settle. So let's say you decide to write your own package. Exciting times, I guess. Now, I'm all up for jumping into existing packages and allowing some flexibility, but for the purpose of this talk, this doesn't exist. We're talking about writing a new package. So this link, absolutely fantastic. It's a great talk called Python for Humans. It's by a colleague of mine. It gives some pretty good insight into the best way to build packages and making them for human use. So public service announcement. This is how I operate. I borrowed these methods from cool packages I found, or tips and tricks from others. I've gone through a few different processes, iterate how I work, and this is where I've landed. That's surely going to change in time, but for now, this is where I am today. So it may work for you may take something away from it, it may not work for you. So when preparing for this talk, this is where I came from. This idea of SOA, or service-oriented architecture. It came about in the 80s, as with everything else fantastic. And that was in a time when buzzwords were all the rage. We had things like Corba, IDLs, and that was the 80s. But now we're talking about monolithic applications, so combining all your logic into one app. You keep adding new functionality, you keep adding installed Django apps, the code base grows, you write more tests, and a fault in one part of the app might destroy the whole thing. It gets cumbersome to maintain and an absolutely huge repo. SOA, on the other hand, focuses on separating out those concerns. You break them out into services, you make them communicate over a transport such as HTTP or 0MQ, and the idea of SOA from very high up is a set of distributed systems communicating, each with their own responsibilities. So the idea is that these are loosely coupled. So over here, payments may need to talk to subscriptions, may need to talk to logging, but generally they don't rely on others existing. They're contract-based, so each service is responsible for its own specific domain. Services communicate and offer data or logic contracts. For example, if I have a payment system and a subscription system, the subscription service has the contract of providing active subscriptions. The payment system has the contract of pulling those active subscriptions across and billing them. And then, if they're overdue, suspending them. The idea is that we're using small, sharp tools and focusing each application on a specific part of your total logic. These services should be share nothing, so they're responsible for their own data, and they provide it via APIs. So that payment service that I was talking about before, it may only need to store the immutable ID of each subscription. That's not its domain. It can always obtain further information via the API of the subscription service. Now, building like this, it's not without challenges. So cache expiry, for one. If the payment system continually polls for fresh data and you run into issues with network I/O or ensuring extremely high availability. On the other hand, if you use something such as Redis or Memcache to cache the payments, cache the data on the payment side, you're going to be polling continuously or you're going to be caching data. If you cache data, you need to know when it changes. So cache expiry is a fairly big issue. Working like this as well, it also increases your technical debt. So as a small team, this is fairly painful. Consider your monolithic application like this. It's one maintained, monitored, and reviewed code base. Now split out into separate services, that's 5 separate apps that you have to maintain, monitor, and keep up to date. And what this equals is lots of boilerplate code. And that's what I'm going to be concentrating on. I generally use Flask, and I found that I was putting this into every application of mine. It's basically a converter that lets you create routes as regexes. And this was a lot of copy and pasting. I was storing it in a gist, I was going back to old projects, and basically reusing it over and over. Now, I didn't want to fork Flask and add this into it. I found that was a bit sort of dirty. And I thought, well, it's not a concern of Flask, so they're not probably going to take the pull request on board. So I decided to put the few lines of code into its own package. I put it up on GitHub, put it up on Crate.io and PyPy, and now it's one command to install. It can go on my requirements.txt, and it's an extra 2 lines of my code. So my boilerplate is reduced, I'm not copy pastoring, and I have some integrity with my code. Now, I went out and I did this for all the things that I was using. Lots of different little tools that each have their own domain. Now, I made these easy to use, I documented them, and I took the idea of small sharp tools on board. Now, when you look at Linux tools, I mean, you've got cat which outputs the contents of files, you've got ls for displaying directory, you've got grep, searches for texts and declare patterns, you've got find, which will search your file system, you've got word count, which will do counts of lines, characters, whatever. You can chain those together, so you can find the files and grep for Python and the file names. You can grep for Rhys and the text of those files. Each command has a specific domain and a specific purpose. And I guess that's the difference between making Flask REST tools, a fairly brittle, sort of large monolithic extension for Flask, and it's really non-specific in terms of what it actually does. Whereas these not as non-specific names. So the descriptions of each turn up fairly well when you're searching on Google and in PyPy. They provide simple and direct functionality for my applications. Now, when searching for a way to manage this, I came across Git Submodules, and it seemed to me like there was a lot of moving parts, it was brittle, and with semantic versioning in the cheese shop or a private index, you have a quick and easy way of explicitly getting a copy of the code that you want. Now, in terms of Git Submodules, I recommend reading this article. Once again, it explains better than I can why submodules are not the best choice when building code like this. So I went along like this for a while, and I thought, well, aren't you just offsetting a bunch of boilerplate code into another area when you build your packages and forcing more maintenance upon yourself? And I thought, well, yeah, I've got to do that, and then realised that I'm pretty lazy, so straight after I realised that I can use a bash script. I built up a small set of scripts, making it easy to get started when separating my concerns. So this right here, you create a new package, and it creates all those files for you. I'm all about scripting inefficiencies. I can't explain it or give it enough credit. This XKCD, though, it can. I found that I was going to Google every time I wanted the syntax for setup.py. Now, this script creates files such as this. So directly after running it the first time, I felt like this. I thought that it was absolute Jedi magic. The README, so RST, shows up prettily on GitHub and the PyPy. I'm all about README-driven development. This link gives absolute great description about what that is. Basically, my template comes like this. I've got all the areas that I need to pre-fill in with my data, and goes from looking like this to something like this for a finished package. I have the guides, I've got the sort of direction of where I want to go. When it's pushed up to GitHub, it looks like this. It's pretty. Same with PyPy. I found when I was first writing these packages that I was putting off writing the README. I got into a habit of not writing it, pushing it off and off, but then sort of changed how I worked and got into this habit of shipping a pre-filled README. And I forced myself to do it first because it needs to be done now or it won't be done at all. The README holds all of the keys and it's pretty much the authoritative guide for the direction and document of my packages. So my history file contains a brief but insightful view into the changes that have been made on the package. So I'll go through like this. It'll be basically chronological steps of the version numbers and the dates and a small line for each feature that was changed. Once again, that's restructured text, so that shows up nice on PyPy. My setup PY, this will be open to some scrutiny. This is all I do for importing any sort of package manager. I haven't seen issues yet, it works for me. In terms of the metadata, we've got a version, GitHub URL, the name, a bit of a description. But what we've got here is reading those files I was mentioning before, the history, the README, and the license. You push that to PyPy and it looks nice. It gives all the information that you need. I add an extra command into my setup PY scripts, which is the publish command. With a few presses of the keys, I can do this. I can put it up on PyPy. That's easy publishing. In terms of testing locally, I do test each package. I basically run PyTest plus PyTest pep8. I write my unit test using unit test 2, and I get a pretty good insight into the results of the unit test this way. It's quick and it's easy. I've got some alias set up so I can just invoke the test on my local machine. Or if I want a bit of view on coverage, I can do a full range of the tests. These packages are small, so I get the test results in a matter of seconds. Now, when I'm all ready to push up and testing remotely, my packages are on GitHub, so it's pretty easy for me to get started, and I usually use Travis CI. It's pretty much perfect for these sorts of packages. Now, when using Travis CI, you declare a Travis file. So basically the language you want to use, the services that you want attached. In terms of services, you can get Postgres, you can get RabbitMQ, MongoDB, whatever you need. I declare an end for each test that I want to run. So at the moment I'm running 6 tests with different versions of Flask and different versions of Redis. Now, the install, that's pretty much like a setup function in the unit test that preps my environment. So I'm installing my requirements file, which basically contains all the test runners I need. And I'm doing an install of Flask and Redis for the particular version for that test run. And finally, for the script, that's basically what you want to run your test. So I'm invoking my Travis CI set of tests. What I end up with after that is this. Every time I make a commit or merge a pull request, I get results such as this. I get emails when the build breaks, and it's really simple. So with my development up until this point, I start running like this. I write my code in a feature branch and I'll test locally. If it fails, I'll write code in a feature branch. I'll keep doing that until the test pass and I'm happy with the features. I'll push to GitHub, I'll open a pull request, and Travis test will kick in. I'll do some housekeeping and then I'll merge if I'm happy. There's a little bit more to it, but that's pretty much it. Housekeeping and merge I can do in any particular order. So what's housekeeping? After I'm happy with the features, I'll add an entry to history.rst, explaining the features that have been added, any changes that have been made, and a date. I'll bump the version, and I'll elaborate on the versioning that I use later on. I'll tag that release, so tag it using Git. I'll push to GitHub. Working on a branch, it's easy enough to pull it across, squash it down, make multiple commits, and merge into master. I'll push to PyPy. And I'll create a GitHub release. GitHub have recently released their, what's known as their releases system. So it allows you to basically put in a history of the project and provides packages as tar files via a CDN, which is pretty handy if PyPy is down and you do need to get a copy of your code. And after all that's done, I'll celebrate. I've just pushed a new release in my code, Cell 5. So with all of this in mind, my releases are easy. I get to start sooner, I get to ship sooner, I get to make smaller changes, My changes are easier to track. So I mentioned before that I'm going to elaborate more on versioning. In terms of versioning, I'm a big fan of just semantic. It's pretty much the de facto, the way to go. So the link down the bottom links to semver.org, which is a pretty good overview of it for those who haven't gone through it. Now, semantic versioning looks a little bit like this. You've got a major, a minor, and a patch, and you can add additional metadata to the end. That's your major, minor, and your patch, and you don't always need to include the metadata. So your major revisions, they're going to break backwards compatibility. That's a major change in the API of your code. In terms of minor, that's backwards compatible functionality. It's still going to work. You might want to throw some deprecated warnings, but it's not going to break too much. In terms of patch, they're backwards compatible bug fixes. That's in between your minor releases. Nothing much does change between those. So when I am working with Python packages, I'll always use explicit versions, be it in the requirements that my setup.py has, or be it in my requirements.txt. The only problem you'll encounter using this method is a maintainer overriding or deleting an old version, but it's much better than breaking your package by grabbing a bleeding edge requirement. So it looks like instead of going from this, you explicitly declare your version numbers. So on from that, I'm a pretty big fan of extending already existing packages. There's some great tools out there with a lot of man hours that have been spent on them. They're fantastic, they're stable, but sometimes they're a bit hard to use. DNS Python is one of them. In my role at Heroku, I make use of DNS lookups fairly often to find out what's wrong with customers' setups. And I found that shipping DNS Python code around was becoming an absolute nightmare. The amount of boilerplate code that you have to get it up and running is pretty big. So it's not easy to use. I found myself Googling for the docs a fair bit. So I ended up building a nice API on top. I released that as a new package. It's private at the moment. It'll be public soon. And therefore, I have easy DNS via a new package. But then I found I was shipping that around a bit much, almost repeating myself. So I built a RESTful interface on top of that. I then released that as a new package and shoved it on Heroku. So straight away, I have central DNS lookups, uncached, just DNS results. And in 2 lines, 3 lines, I can get the results of a domain. So I also have some other packages built on top of Supervisor and a few other ones built on top of different other libs. I got no problem chaining these dependencies if the original projects are well run, maintained. And on the topic of maintaining and new features, basically when I'm iterating through changes in these packages, I'll just rinse and repeat. Semantic versioning, I'll use explicit version numbers, and I'm testing both locally and with Travis CI. If a new version of Flask is released, I'll add that as a package to test against, and if I add a new feature, it'll be tested. If something breaks, I'll receive an email. It's pretty stable for the most part, and I haven't encountered many problems. So when starting with Git and sort of creating these packages, I sort of thought, well, the world's watching and this code's public. You start to get some expectations on yourself in terms of feedback and pull requests and new features. And dealing with these feedback and pull requests and features can be hard. This article gives a pretty good overview of the attitude that should be displayed, and I'm hoping to see more of it online. Committing to open source, especially for first time, can be hard. We don't want to scare anyone off, and I guess it should be more about education and self-growth, helping others, and not about ego. So I started building these packages, and then came to realize that I didn't want some of them public. Some of them were internal IP, didn't want to share them around. So what I came to for this was private package indexes. They do exist, and serving internal packages is fine. This link down the bottom links to Local Shop, which is a pretty good private package index. It works with pip. You can still go through the same process of what I've outlined. In terms of security, availability, and protecting your IP, it's a good way to go. So pip install local shop, or you can clone the source. It gives you authentication, IP restriction, and it's just a mix of Django and Celery and a few other little dependencies. Then you can run local shop. The command's a bit more full on than that, but it's pretty easy to get up and running. You can then edit your pip file. and you can point your local pip towards it. So what it will do, if you install a package that's recognized on the cheese shop, it will go out, it will grab it, and it will cache it locally. It's pretty handy to run. I take it with me on my laptop, so when I'm traveling, flying, I can install packages, without having an internet connection. I can be off the grid and not have to worry if I need something. In terms of private packages, it works exactly the same way. You can upload, you can download. If you've got something you don't want available on the actual public cheese shop, it's a great way to go. And most of all, it gives you some security. The chance is low, but a rogue agent, so ex-employee, hacker, someone a bit disgruntled, or the NSA, there is the possibility of them introducing malicious code into an old release and no one picking up on it. So it's not likely, but it could happen. I guess this allows you to isolate some public packages from the outside world, and it may be part of your security requirements anyway. Now, something I picked up at Heroku is Git in the requirements.txt. Now, we do allow this. It is allowable, but I found it to be fairly brittle in terms of how it operates. I've seen a fair few problems just where the behavior is not as expected. If you declare a branch that you want to include as a package, there is some problems in terms of caching. I think that a cleaner way to go is just use the package name within requirements.txt, and if you do have those packages you want to pull from Git, put them onto a private index instead. Now, in terms of staying up to date, if you're writing packages on packages, or relying on, or relying on some other dependencies, how do you stay up to date? I found that mailing lists are pretty good. You get informed of new releases. You can get to join in the discussion around the package. Also puts you in touch with the maintainers and contributors of the package, so it's pretty handy for wrapping your head around it. I also watch the GitHub repository. It does spew out a fair few emails when it's busy. It does generate a fair bit of noise, but it's good to get a history of what's happened, especially with pull requests. Where I've come to, though, is I'll hack PyPy. So down the bottom, that's a link to the PyPy API. I've written a script which holds all the packages I use, and 2 times a day, there's a Heroku app I've got running. It'll check for any new releases, and it'll email me if there is any new releases. So this means, basically, if there's an update to Flask, I can receive word of it, and I can get to updating my packages sooner. So with all this writing small, sharp packages, you get what works for you. So you control the destiny of it, you find something that works, and you don't have to rely on others. You can also help the community, and it keeps you up to date with the current ecosystem. You get to see what other packages are floating around out there. It sort of widens your horizons. And most of all, it gives you practice with actually getting these things up and running. In terms of trade-offs, you start to spread yourself over more and more work. Maintaining can be a bit harder. Each package you add adds more man time that you have to worry about maintaining. And within your files, you end up with a large amount of dependencies. There's also possible performance issues. I haven't seen them yet, only when building projects. And shared nothing can be troublesome when you have a lot of sort of systems and a bug is introduced. You don't want everything that's using that package to go down at once. Now, some people do say that we don't need more packages, we don't need more deadwood, but if it's actively updated and sort of floats to the top and the community does get behind it, people will expect that it's maintained, and hopefully there is a bit of interest in there to help you sort of maintain it. I guess, think about it though, we've got these packages out there. These ones, along with a lot of other great packages, they mostly do one task, and they do it pretty well. Someone's put their time and effort into making them awesome. Someone wanted a great tool to do a job, and they're putting lots of hard work into it. So you look at these packages, and then you look at our sort of package ecosystem, and we've got a variety of packages. They're easy to use, they've got beautiful APIs, and how we get them and how we update them, it isn't as bad as a lot of other languages. As a dev, things become easier. It makes your professional working life a lot easier. Your personal tool belt that you carry around with you, your packages that you always rely on, it improves. You get to help others, so giving back to the community is always great, and you stay up to date. You might learn something, and most of all, you get to enhance your professional skills. So, a recap. You want to script your inefficiencies. I script the hell out of my daily life and I make it available for others. I'll put these scripts I've talked about up on a gist and put some links at the end of my slides when they go on Speaker Deck. I've got countless aliases, .files, bash scripts, which automate my mundane tasks. I know they're pretty badly written, but they work and they save me time. If you take something away with it from it, that's great. Testing. Make sure you test and test often. It's not hard and it's going to stop you from introducing problems into your code and into others' systems. Build your own procedures and what works for you. So if it's tested, easy to deploy and not too difficult, congratulations. Everyone's different though, so you might need to tweak the formula. What I do might not work for you. Reduce the time to release new features. So make it so the conception of the idea to releasing the actual new version is a short, pleasant experience. And most of all, if it doesn't exist, build it. This helps improve our ecosystem of packages. Commit to open source. Who hasn't committed to an open source project? Do it, please. It's not scary, it's a great feeling. Make the packages beautiful. Make them easy. Make them functional. Stay up to date. Small, sharp tools. Give back to the community. And most importantly, have fun with all this. Development's a great job and we're incredibly blessed. Cheers. So I rushed through that. Does anyone have any questions?
Oh, sorry. He's fast.
So my question is about, you talked about great ways of versioning Python packages and all that stuff. Do you have any way of sort of looking for underlying OS dependencies, like if you need a certain apt package or whatever?
So
any tips on that?
In terms of, say, image magic or something like that?
Yeah, well, hopefully not that, but yeah.
I guess 12-factor stipulates that, say, you've got image magic and you know you're going to be working on, I guess, Ubuntu 12.04. Vendor it in. You can't always expect it's going to be there. That's where I've sort of ended up. I used to run shell scripts to try and work out where it was, but I couldn't rely on the versioning information. I found it much easier to be explicit and vendor it into your package. It's not hard to build it on a Ubuntu system, vendor it in, and then add it to the path. So that's how I do it.
All right, thanks.
No worries. And the same goes for Postgres libs as well. But I mean, you can always rely on a tool such as Puppet or Chef as well, next to your application to make sure those dependencies are there. But yeah, I found vendoring is the best way to go.
So in your workflow, you actually issue a push request against yourself when you upload a new version of something?
So I'll push to the branch, and then I'll open a pull request, and that lets me get the Travis test results.
Right, but that push, you're opening a pull request against yourself?
Yeah.
Okay. Yeah. And then who's running the Travis CI? Is that GitHub doing that for you?
So it will push a hook out to Travis CI. Travis CI will grab the repository, test it all, and then push information back to that pull request.
Okay, so Travis CI is another software as a service. That's a thing like Sentry where it's doing the thing for you?
Yep.
Okay.
Yep. It's non-host, like you can't host it yourself. It's basically a third-party service running in their system. I think they've got plans for a private edition, but not too sure.
Okay. Any other comment? Okay. So we will have lightning talk and closing session in the third floor main hall. So I'd like to close this session now, and thank you very much for the presentation.
Thank you.
何時からでしたっけ？5時半かな。あんま時間なかったよね。40分。So the closing session, and before the closing session, we have lightning talk session at the hall located in third floor. It will start 5:40 p.m. Thank you.
Cheers. Oh, yep.